I think everyone knows Alex, and please make a double applause because he's been organizing all these conferences for so many years, putting a lot of effort. Thank you, Alex. And now,
thank you so much, JP.
SGAI, but in the 6th edition of MPEG Dash that was just mentioned.
Okay, so when I saw that David is speaking before me, first of all, I thought, okay, shit, I don't have anything to talk about. But then I realized I can drop at least 6 slides of introductions. So now for something completely different that you haven't ever heard, server-guided ad insertion. So what we're going to talk about is alternative MPD events, which is now, as of the upcoming 6th edition, the preferred way of implementing server-guided in Dash. And we'll cover only 2 things, since we already had the perfect introduction, how this thing works in Dash and what are the advanced use cases that we cover. So in a nutshell, a very simplified version of the same diagram you've seen. We have, in Dash terms, main content that contains alternative MPD events, and this can be roughly described as metadata on ad break timing and URL. So you may ask, why not use SCSI-35? The problem is SCSI-35 is perfect describing that opportunity, but it's not interoperable. You don't know what to do about it in a generic way, and this is what alternative MPD events fix. So the client executes the event and switches to alternate content, and at some point comes back. Then we have the SGI endpoint, which receives an ad request, basically receives a URL with a ton of various parameters, translates it, let's say, to VAST, talks to an ADS, gets a response from the ADS, and returns the alternative content MPD to the client. So, what is an event? So we can think about it in general as timed metadata. So you have information about timing. This is when the event should be presented. This is how long it lasts. Then the rest is scheme specific, and scheme is Dash speak for a type of event, same as it is event class. Sorry, there is data range class in HLS. And there are 3 ways of doing this. As usual, Dash has way more ways of doing the same thing. So you can carry this in the MPD, you can carry it as a box in a segment, or you can carry it in a separate track, timed metadata track. Then there is the execution, and the execution that is generic is very simple. You see an event, you see it when the client becomes aware of it. Let's say it sees the first MPD where it appears, or it sees the segment. And then there are 2 modes. You either dispatch it to the application that knows what to do with it when you see it, it's called on receive, or when it is supposed to happen. And this is an illustration of what happens. You have an arrival time, you have a time at which the event starts, and you have a duration for it. Now, what is the metadata that we have in alternative MPD event? We'll go first through the metadata and then through how it actually works. So we have 2 types of events, insertion and replacement. The diagram here shows insertion. What you have is an alternative MPD URL. Here is what we are going to get. We issue an HTTP GET and get a playable MPD. And then timing, which is a little bit more involved. First, when is the earliest time when you can download this MPD? And this is needed to go and be, on one hand, close enough to the ad, on the other hand, to be able to prefetch. Then when to switch? When is the switch possible? And then the last thing, which is optional, is how long are we going to play this thing for? And the illustration here shows that we have some time to prefetch the event. We're starting it in time. We're playing the whole presentation. We're returning and resuming the playback from the same point from which we started. So this is insertion. This is the most simplified way of doing it for VAD. Replacement is a much more interesting way of doing things. The key difference is you go and while you are playing the alternative media presentation, your main client is in listen mode. Listen mode is a mode in which you are not rendering anything. So MPDs get updated, MPD chaining is followed if you are using it, and most importantly, events are processed. Since events are processed, replacement events are processed, and replacement events can be updated, same as SCSI 35. So what you can do, for instance, is send an event that says, play this thing, so play this alternative MPD for an indefinite amount of time, or for 15 seconds, doesn't matter. Then all of a sudden, while you're playing, you're issuing an update that says, okay, we actually need to go and stop the playback here and not where we intended, and you'll stop it earlier. So this is the classic return to network thing, which wasn't easily doable before. If you want another piece of trivia here is you don't have to return to the same point time-wise, so you can have the same amount of time elapsed, or you can actually explicitly define where you're going to return on the timeline. Now, what do we do conceptually? Because people start getting lost in lots of acronyms and timelines. We have two very simple data structures conceptually. We have a table where we keep all the events with their IDs being unique keys, and with counters that say this is how many times we started this ad, and this is how many times we actually completed the playback. Then we have a queue, or more precisely a priority queue, with the key being the scheduled time. So this is the presentation time translated into wall clock time. So this is what we're working with. And the simplified version of processing, we have two parts. What happens when the event gets dispatched and we as an application read it? So we know that events are unique, globally unique within their scheme, identified by ID. We see, have we seen this event or no? Is it an update for an existing event? If it's an update, we'll update this in the table. If we need, we'll reorder the previous queue. If it is a new one, we'll add it, and we'll add it to the queue if and only if it is still within its active interval. Active interval in this case is duration. So is this, the presentation time and duration. Then we'll have something that can be seen as a busy loop if we're not writing an actual code. And the algorithm there is trivial. If the client is in listen mode, do absolutely nothing. You cannot process an event. If you are either playing back the main representation or you just came back from the previous event, you go and you take the topmost event from the queue, so the most recent one, and execute this event, and go on. Once you're back from listen mode, you get the nearest top event, and then if you don't have anything that is past due or sufficiently close, you go back to playing main. So the previous slide. Okay. So previous slide has an example. We have three events here. One of them has the date of Skynet becoming self-aware. So whenever you join the stream, it will always play first, and then there are more reasonable events that can be played at their time. So putting this all together, I think I'll probably try to skip most of this, but the point here is we have additional options beyond what is specified in the slides. We can specify exactly what's the maximum duration, so that we retain control over how much of the ad we're playing. We have ways of saying how many times do you want to execute this ad. Do you want to execute it only once, or every time you encounter it, it will be executed? This is why we needed counters in a table. A couple of interesting exotic options. So first of all, we want to customize the URLs and add two things: parameters that we want to pass through and parameters that describe the state of the client. This is what we need to go and have this one-on-one relationship between the ADS and the client in terms of decisioning, and at the same time have something that is perfectly cacheable. So there are two things we can do. We can, in terms of internal state parameters, we have several things defined. Let's say current language, codec bandwidth, how far we are into the current break, if we are somewhere in the middle. Then we can go and reflect parameters. Reflecting means, let's say in the beginning of time, you issued a GET for your first MPD. You got a redirect with a query parameter. So you will remember this query parameter, and you can go then and insert it into different requests. So here we're inserting it into a request for alternative MPD. So this is how you can do, for instance, session ID, or you can say we're playing in English. This is our bitrate, and so on. And you can go and include it in various different requests, including alternative MPD, content steering, and so on. List MPD, that was already mentioned. So what it is basically X-Link done right. So you have a list of periods. Periods may have content, but they have an imported MPD element that says this is the actual MPD from which you want to get the content, and this is the earliest time at which you want to go and download this MPD. And then there is a well-defined merge process. One of the goals of that merge process is you would get at the SGAI endpoint the beaconing information, but you would be downloading the MPDs at the client. So you want to be able to go and merge the two, so that when you go and play the period, you'll have both at the end of the resolution process. So in the end, you can create a list like this, and the inspiration for this was obviously much simpler than the Dash result. It was the X asset list that David talked about. One use case that is handled in Dash, but for now doesn't exist in HLS, is blackouts. So blackouts in US are a painful thing when you all of a sudden, for rights reasons, cannot play a certain football game. So you need to go and switch to some different content, and then switch back. So you can do this using alternative MPD event, and then the alternative content, which is let's say ESP, you had ESPN1, you switch to ESPN2. It also may have ads. So you have a second level of alternative MPD events. You need to be very careful with this, because if you go and start adding more and more levels, it'll consume more and more resources. So on the Dash F side, we'll probably need to limit this. Last thing, partial ad breaks. So you can have a situation where you joined in the middle of the ad break. You still want to go and sell whatever is left from it, and then Dash, as usual, gives you two ways of doing this. You can go and play whatever remains and get back to the main content at the point which was conditioned, or alternatively, you can go full pre-roll and go and play the complete thing. The downside is there is no conditioning there. The upside, the good thing about it is the same 6th edition adds L3D Dash, so it's low delay, and low delay allows you to go and start playback at an arbitrary location, or reasonably arbitrary. So you can use this to go and emulate unconditional. I have 50 seconds, 2 slides left. Prefetch and scalability. So we talked about prefetch, that you can go and do the fetch early enough. If you have something that is high concurrency, you have a lot of clients requesting the same ad 4 to 8 seconds before it starts. Makes no sense. What you can do is you can announce 10 minutes ahead of time or a minute ahead of time, doesn't matter. There will be an ad break at this time. You actually have no idea that there will be a break. You know that most probably there will be one, but you let your client go and at random time, between the time that you announce and the earliest time at which you can download, you can go and download at that point, and then you can send a few seconds before an update that says, actually, this is when the real break is, and this is how long it is. And we have 2 seconds and a very brief summary. So alternative MPD events introduced in 6th edition. 6th edition is going for final ballot. This is a ballot where you can only do fix typos in about 4 weeks. So we're almost done, and we won't have any more changes. That's it. We're going to ballot. Thank you so much.
Thank you, Alex, so much. Any quick questions? Okay. I guess you're worried about implementing all these.
Thanks, Alex. I actually have one question and one comment. Maybe first a comment. So, I mean, you guys at Collabs did the first implementation of that, and I think it's not straightforward to do that with MSE-based players because there are limitations regarding the source buffers, having multiple source buffers, etc. So what we did, at least Tasso and I did that, we met with the W3C guys and asked for some extensions to MSE, but I think that should be considered here because if you have this approach of using multiple video elements, that has some downsides as well. So I think it's good that Tasso is included in there, but there might be some things that are not implementable with MSE-based clients. And my question was, so you showed this more or less switch back to the network based on events, right? So
Yes.
Do I, as a client, have to monitor the mainstream of all the time?
Yes.
Download segments, parse EMSG boxes, although I'm not rendering the segments, I'm showing the other.
If you want to use EMSG, you do need to go and download segments, but you don't need to actually download the complete segment. You know exactly where the MSG box will be in the very beginning. So you can say, let's go and download the first kilobyte.
So I'm doing byte range requests on the segment?
Yeah, so byte range request for the first kilobyte, so this should fit a single frame.
Okay. And these byte ranges are signaled?
They're not signaled. You can guess because you probably won't have 1 meg event. So this is a hack. Now you will definitely know what is the size of the box because definitely it will start in the very beginning of the segment, and it will have its size at the very beginning.
All right.
Then, in terms of your previous remark, you don't have to implement it into different players. You can go and actually manipulate your buffers and keep it within a single player. Yes.
Okay. Hi, Alex. Just a clarification, and you were mentioning that this would replace the concept of X-Link. In edition 6. How is X-Link being defined, or is it totally removed?
Nothing is removed. The only thing that removes X-Link is a profile that is defined in the new profile that is defined in MPEG. But you can go and still use X-Link. The problem with it is that unfortunately it is ill-defined in terms of timing. There is no good definition when are you supposed to fetch it, except for the case where you are fetching it immediately as you parse the MPD. So that's one of the problems with it.
Okay. Thank you very much, Alex. And another applause, please.